All right, the Pythagorean Theorem and its converse. All right, way back a long time ago in ancient Greece, this guy by the name of Pythagoras was really good with geometry and figured out a lot of things. And one thing that he figured out was that in a right triangle, the square of the hypotenuse was equal to the sum of the squares of the two legs. And you go, what you talking about, Mr. Bierschbach? Well, I'm talking about the Pythagorean Theorem. But instead of talking about hypotenuse and legs, we can make the Pythagorean Theorem a whole lot easier by making the hypotenuse C and the two legs A and B. So that C squared equals A squared plus B squared. There. Now that's a form that you've seen that you can work with. Okay? So if C squared equals A squared plus B squared, and I want to figure out what X is right here, X is the what of that triangle? The hypotenuse or a leg? Hypotenuse. So that's C. So that goes in the place of C. So X squared equals, and make this A and this B, 3 squared plus 4 squared. So X squared equals, what's 3 squared? 9. 4 squared? 16. 9 plus 16 is 25. And then we want X, not X squared. So we take the square root of each side. X equals 5. Easy peasy, lemon squeezy. Here's another one. 6, 24, what's X? Now, that X is not the hypotenuse, it's a leg. So 24 squared goes on one side, and then 6 squared and X squared go on the other side of the equation. So 24 squared is 576, right? This is 36 and X squared. So if you subtract 36 from each side, 540 equals X squared. Now if it says find a decimal round to the nearest tenth, you just use your calculator and find it. If it says simplest radical form, then we have to break it down, and that's what we'll do next on the next problem. But for this one, let's find a decimal answer, rounded to the nearest tenth. So it would be 20-something. 23.2. 23.2. Okay. Now, this one, we want, let's say the directions say we want simplest radical form for this. So, what's this side called? Hypotenuse. Okay, the side opposite the right angle is hypotenuse. So 9 squared, the hypotenuse squared, equals 4 squared plus X squared. 9 squared is 81 equals 16 plus X squared. We subtract 16. X squared equals 65, and then take the square root. The square root of 65. Now, does that have any perfect squares on this list that go into it? We got some no's. Yeah. So then, this is simplest radical form. Sometimes you don't break them down at all. Sometimes they just stay because there's nothing that goes into it. Sometimes there are things that go into it, just like this one will have. So on this one, what's your hypotenuse? X. So X squared equals 2 squared plus 4 squared. So X squared equals 4 plus 16. So X squared equals 20. We take the square root of each side. What's a perfect square on that list that goes into 20? 4. How many times? 5. So X equals 2 square root of 5. Okay. Perfect square, or simplified radical. Okay. Simplest radical form. Let's find C here. Ooh, there's radicals in the legs. C squared equals the square root of 5 squared plus 4 square root of 5 squared. The square root of 5 squared is the square root of 5 times square root of 5. What's square root of 5 times square root of 5? Square root of 25, which is 5. Okay? So this is 5. 4 square root of 5 squared is 4 squared, which is 16, times the square root of 5 squared, which is 5. 16 times 5 is 80. Okay. So C squared equals 85. So we take the square root of each side. C equals, there's no perfect squares that go into there. So it is simply the square root of 85. All right, that's the Pythagorean theorem. Now we have the converse to the Pythagorean theorem. If C squared equals A squared plus B squared, then we're talking about a right triangle. If C squared is less than A squared plus B squared, so C has to be on the left. You have to write C on the left when you do this. If C squared is less than A squared plus B squared, it's acute. Less than acute. Smaller acute. If C squared is greater than A squared plus B squared, it's obtuse. So in this triangle right here, 8, 11, 16, is it right, acute, or obtuse? You're just thinking. You're just guessing. Let's know. So, C squared, we're going to compare it to A squared plus B squared. What's C in this case? 16, because that's the longest side. We're going to compare it to 8 squared plus 11 squared. 16 squared is 256. We're going to compare it to 64 plus 121. We're going to compare 256 to 185. Greater than, less than, or equal to? Greater than. What is it? Obtuse. Right is equal to. Obtuse is greater than. Now, I had some people make mistakes in the earlier class because they went A squared plus B squared equals C squared. Okay? You got to have C on the left. Less than is acute, greater than is obtuse if C is on the left. You put C on the right, then it totally changes things. 5, 12, 13. How does 13 squared compare to 5 squared plus 12 squared? What's 13 squared? 169. Compare it to 25 plus 144. What's 25 plus 144? 169. They are equal to each other, so it is a right triangle. Let's do one last one. What's the biggest number here between 6 square root of 3, and 12? Well, how can I tell if 6 square root of 3 is bigger than 12? Well, just do it on your calculator. Take 6 times square root of 3. See if it's bigger than 12 or not. It's 10 point something, isn't it? 10.4. So it's not bigger. So 12 would be the hypotenuse if it's a right triangle. 6 square root of 3, something like this. So 12 squared, you're comparing to 6 squared plus 6 square root of 3 squared. So 144, you're comparing to 36 plus 36 times 3. So you're comparing 144 with 36 plus 36 times 3? 108. 108 plus 36 is? 144. They are equal, so it is a right triangle. Okay. So that's all we have for that. I will hand out the worksheet. I will grade your tests, and at the end of the period, I will get your tests back to you.